Think about it for a second. Your brain. It's probably the most complex, most precious thing in the known universe. And it lives inside a fortress, sealed off and protected by some seriously intricate defenses. But what happens when that fortress gets breached? Today, we're going to tell that story in 3 parts. We'll look at the fortress itself, what happens during a breach, and then we'll dive into a revolutionary new technology that can not only repair the damage but actually reinforce the walls for the future.
So, let's just jump right in. Our bodies are constantly dealing with, well, everything. Toxins, germs, wild chemical changes. How on earth does our brain, this incredibly sensitive command center, keep its environment perfectly stable through all that chaos?
Well, the answer lies with its primary guardian. It's a structure so crucial and so smart that we call it a barrier, but honestly, it's much more than that. It's more like an intelligent gatekeeper. Let me introduce you to the blood-brain barrier, or the BBB for short. Now, this is not a simple brick wall. It's a living, dynamic border made of specialized cells that are packed together incredibly tightly. You should think of it less like a wall and more like the most advanced, most sophisticated border security system you can possibly imagine. And its job description is intense. The BBB is like a bouncer, physically keeping harmful stuff out. It's also the quartermaster, carefully checking IDs and letting only essential nutrients, like glucose and oxygen, get through. Its main goal is to maintain perfect stability, a state called homeostasis, so your neurons can do their job without any interference. And it's not a solo act either. It works hand in hand with other brain cells, called glia, to form this complete security detail.
But here's the thing about even the most impressive fortresses. They can be breached. And a sudden violent impact can smash through these meticulous defenses in a fraction of a second.
A traumatic brain injury, a TBI, is literally a battering ram. When the head is suddenly jolted, the brain sloshes around, generating these immense internal forces that stretch, twist, and compress the delicate tissue. And one of the first casualties in that attack are the tiny blood vessels that make up the blood-brain barrier. They get torn open, and just like that, you have a breach.
And this is where the real disaster begins. You see, the initial physical damage is bad, for sure. But it's the fallout, that secondary cascade of chaos that happens next, that often causes the most severe and lasting harm.
With the gate smashed open, the brain's pristine, perfectly controlled environment gets flooded. All sorts of substances that are normally kept out of the brain now come pouring into this delicate neural tissue, triggering a full-on biological state of emergency.
And the damage these invaders cause is incredibly specific. These aren't just random chemicals. They're proteins from the blood that each kick off their own devastating chain reaction. You've got fibrinogen, which basically puts the brain's own immune cells on high alert, causing scarring that actually blocked neurons from repairing themselves. Then thrombin comes in and unleashes a firestorm of inflammation. And then there's albumin, which can set off a chain of events that we now know is linked to seizures and epilepsy after an injury.
Now, all this flooding also causes dangerous swelling, or edema, and it's a double whammy. First, there's vasogenic edema. That's when fluid leaks out of those broken blood vessels and floods the spaces between your brain cells. Then you've got cytotoxic edema. That's when the brain cells themselves get so stressed out by the chaos that they malfunction and start swelling up from the inside. Both of these dramatically increase the pressure inside your skull, which, as you can imagine, leads to even more damage and cell death. So you can see, the damage isn't just a single event. It's a horrifying cascade. And that's why this quote from Dr. Daniel Antonetta hits so hard. He's saying that if we can just get in there and intervene early enough, we can stop that cascade. We can prevent lifelong disability. But how? That desperate need for a better way to restore order brings us to our next chapter.
All right, so this brings us to the really hopeful turning point in our story. For decades, medicine has really just focused on trying to patch the holes after the damage is done. But now, scientists are developing a way to reinforce the fortress from the inside out.
What if we could just bypass all that chemical chaos and communicate directly with the neurons themselves? What if we could listen in on their distress signals with unbelievable detail, and then send back our own commands to help calm the storm?
The key to this whole idea comes down to this number, 65,536. That's the staggering number of electrodes that are packed onto a tiny new implant. It's called the Biological Interface System to Cortex, or BISC. Every single one of those electrodes is a microscopic listening post, able to record the brain's electrical chatter with absolutely stunning resolution.
And then there's this number, 100 megabits per second. That's its communication speed. To put that in perspective, that's more than 100 times faster than any other wireless brain interface out there today. This incredible bandwidth is what could finally turn the brain's closed-off fortress into a high-speed data port.
You really get a sense of what a game changer this is when you put it side by side with the old tech. Traditional brain-computer interfaces, or BCIs, are these bulky canisters with a bunch of different parts and wires, and they require major invasive surgery. The BISC, on the other hand, it's a single, tiny, flexible silicon chip. It's as thin as a human hair, completely wireless, and it can be slid right onto the surface of the brain with minimal surgery. It's a whole new ballgame.
So what's the secret sauce? It all comes down to integration and design. Everything, the radio, the power source, all 65,000 of those electrodes, is on one single piece of silicon. And it's so incredibly thin and flexible that it just lies on the brain's surface, as one researcher put it, like a piece of wet tissue paper. It creates this seamless, high-bandwidth connection with almost no trauma.
And this is where the story just gets so much bigger, because this isn't just about repairing damage anymore. This kind of technology opens the door to an entirely new era of interaction, a direct connection between the human brain and artificial intelligence.
The immediate applications are just staggering to think about. For epilepsy, the chip could detect a seizure the very instant it begins and send signals to stop it in its tracks. For someone with paralysis, it could decode their intention to move a limb and send that command to a prosthetic or maybe even back to their own muscles. For blindness, it could one day take data from a camera and translate it directly into neural signals the visual cortex can actually understand.
So you see, the BISC isn't just a single medical device, it's a platform. It's kind of like the invention of the USB port, but for the brain. It's the hardware that could finally allow the brain's complex biological code to interface directly with the clean logic of an AI, creating a true seamless partnership between human and machine.
And that brings us to our final and maybe our biggest question. We started this whole journey talking about how to defend the brain. But this new technology, it suggests a future where we don't just defend it, we augment it, we expand it. So when the fortress in your head has a high-speed data port connected to the outside world, it forces us to ask a really profound question about our own evolution. Who, or maybe what, are we becoming?